These are in listen-only mode.
Hello, everyone. Welcome to today's webinar. Thanks for joining us. Today's topic is Whole Building Control from Concept to Reality. I'm Ann Cosgrove, the Editor-in-Chief of Facility Executive Magazine, and this webinar today is presented by Mitsubishi Electric. Before we get started, I'd like to cover a few housekeeping items. Please note the control panel that is on your screen. This is where you can submit questions via the question box in that panel. You can send your questions in at any time, and your speakers will address them after the presentation. Also, please note the orange arrow on the left side of your panel. Clicking on that will either expand or collapse the panel, so please be sure it is expanded so you can access the question box. Also, if at any time you do experience technical difficulty, please send a message to us in that question section, and someone will get back to you right away. Now, let's jump into it. I'd like to introduce your speakers today, and they are Kevin Miskowitz and Ed Blair. Kevin is Mitsubishi Electric's Director of Commercial Marketing, and in this role, he leads programs and initiatives for the division's commercial product line. Kevin is a certified lead green associate, and he earned a bachelor's degree in business administration from the University of Dayton in Ohio. Your second speaker is Ed Blair, and he is Manager of Controls Solutions Training with Mitsubishi Electric. He has more than 12 years of controls and training experience and supports the Controls Solutions Group at the company, extending the capabilities and applications offering of city multi-VRF as well as residential equipment. Ed previously served as controls engineer at Mitsubishi Electric and also has prior experience in automation, project management, and engineering. He earned his Bachelor of Music and Music Education from Berry College in Georgia. So with that, I'm going to hand it over to Kevin Miskowitz. Hi, Kevin.
Thank you, Ann, and good afternoon to everyone on the phone. On behalf of Ed Blair, I want to thank you for the time that you've chosen to invest in today's session, and we believe that you'll find the content that we're about to present to be quite valuable. As Ann mentioned, we'll spend time discussing advances in whole building HVAC controls, including trends in the industry and the innovation that led us to this point. In addition, we'll touch on the future of whole building control within the commercial space. Our goal today is to showcase the rapid innovation in response to trends in the HVAC controls industry, leaving you with a better understanding of how these innovative control solutions can work for your clients and your buildings. Today we will cover the following topics: trends within the HVAC industry, specifically focusing on connections to electronic controls, a historical overview of controls within the HVAC industry, a look at present-day HVAC controls, ranging from individual zone controllers to whole building controls and ultimately automation systems. We'll showcase a couple successful applications of HVAC controls, and we'll have time at the end for questions, which can be submitted throughout the webinar. We look forward to spending time at the end of the presentation addressing the questions you might have about whole building controls. So let's start out discussing a few high-level trends within the HVAC industry. The demand for energy-efficient mechanical equipment has been and continues to be a major trend within the industry. With energy and other utility rates constantly fluctuating, a building owner is always looking to invest in efficient technology for their operation. Whether through government regulation or the desire to gain market share, the HVAC industry's key players have been ratcheting up efficiencies over the last few years, a trend that we strongly believe will continue into the future. The demand for space-saving, flexible equipment has a direct correlation to the increasing demand for architecturally pleasing building designs. As building design becomes increasingly focused on style versus purely functional, there is a demand for mechanical systems that are flexible enough to adapt based on those designs. In addition, the space-saving elements enable the building owner and architect to design around their vision, while not impacting the engineering community or facility management community, whose core responsibility lies in designing and operating mechanical systems that achieve a building's conditioning requirements. Now let's talk about how those trends extend into the HVAC controls space by discussing the demand for personalization, which is becoming more prevalent in buildings today. This trend, which crosses many different platforms and mediums, has made its way into the HVAC industry over the last few years. Building occupants who have become accustomed to living in the information at your fingertips era are now seeking ways to personalize their comfort within an occupied space. Having the capability to personalize occupant comfort ultimately leads to happier tenants, which makes the building owner and facility manager's job easier. As personalization becomes more prevalent, there's also a demand for better control over mechanical systems within a building. Control over those systems comes at two levels: centralized and locally within the space. Centralized controllers can range from building automation systems that control all mechanical equipment within the building to controllers that control all aspects of one mechanical system, such as the HVAC system. Controllers within the space provide occupants the ability to personalize their comfort within that space. Demand for both types of control, both centralized and local, continue to rise within the HVAC industry. With that, we'll now turn it over to Anne for the first of our two polling questions today. Anne?
Thanks, Kevin. Okay, so yes, we'll ask all of you in the audience there to take a look at the poll question that's on your screen. And it is, which of the following applications do you work with the most? Are you working in office building settings mainly, multi-tenant, retail, K through 12, schools, or other? We'd like to get kind of a sense of what types of facilities the audience is working on. So what do you work on the most? Please take a moment to cast your vote, and then we will show the results shortly. Okay, so the results should pop up shortly, and let's see what we have. Okay, so we have 35% office building of our audience, 35% is other, and then a 15-15 split with multi-tenant and K through 12. So thank you very much for sharing that with us, and we'll take it back to you, Kevin.
Thank you, Anne. That's definitely good information for us to know. We'll talk a little bit about a few applications in different spaces later on in today's presentation, but adaptability and flexibility is certainly a hallmark of today's controls offerings, and I know Ed will touch a little bit on that later in the presentation. So thank you, everybody, for your information that you were able to provide. So let's turn our attention to a few more trends within the HVAC space before we hop into a more in-depth look at the controls that we'll discuss today. Now more than ever, building owners, occupants, and managers demand intelligent functionality from their mechanical systems. Today's systems, including HVAC, often feature two-way communication from their electronic controls. The thermostat on the wall is not only a way for the occupant to control their own personal comfort, but a way for the system to sense conditions within the space and potentially adjust automatically. This intelligent cross-system communication leads to an improved experience for the building occupant. Managing a commercial building is oftentimes a very complex task that requires many inputs from various data sources. The demand for an all-encompassing view of how a building's mechanical systems are operating is a requirement of most building owners and facility managers. Being able to aggregate operating data on a building's mechanical systems enables an owner or manager to locate waste, improve the occupant experience, and ultimately run a more efficient operation. And in today's time-starved world, building owners and managers are looking for a one-stop shop solution to aggregate, analyze, and display data on all mechanical systems within a building. Just a few moments ago, I mentioned that we are in the information at your fingertips era. That trend has made its way into the HVAC industry through intuitive mobile-based controllers. There are multiple products and services on the market that let a homeowner, building owner, or building occupant control their own comfort straight from a mobile device. This enables that person to remove the tether of touching a physical thermostat and enables them to make changes on the fly from anywhere in the world. The use of mobile, app-based controls will continue their rapid rise into the future as the home automation and smart home initiatives continue to gain momentum. Now that we've had a chance to look at some of the trends in the HVAC and control space, we're going to take a brief look back at the history of control systems within the commercial building segment, along with the view to where the industry is headed. I'll now turn the presentation over to Ed Blair, Control Solutions Training Manager at Mitsubishi Electric Cooling and Heating, to dive into this topic. Ed?
Thanks, Kevin. I think to know where we're going, it helps to see where we've been in the past and what that means for the trajectory of innovation and controls. Initially, buildings were controlled with pneumatic systems. So they had extra plumbing, piping and tubing with pressurized air to operate pieces of equipment in the building. Maintenance for pneumatic systems is extremely expensive, extremely difficult, and it was solved almost as many problems as it seemed to create with the additional expense and labor. So the pneumatic interfaces were very difficult to interpret. There wasn't very much in the way of data or visibility into what the building was doing or how the system was performing. Logging was almost non-existent, and interfaces with pneumatic systems tend to be very difficult. And back in the bad old days of dot matrix printers and serial connections and lots of difficult parts to upkeep and interact with. In the 80s, direct digital control started to make an appearance in the market, and it was a much improved system because it was much lower cost to install. It gave building and facility managers much more visibility into what the building was actually doing because they could actually see the data back from the different controls. And it was also much easier to service because you can use traditional electrical testing equipment instead of having to rely on gauges and dials and pneumatic tools. The interfaces now with digital controls are much more improved over where the pneumatics used to be. We have live real-time data with touch screens. We have user operator stations on computers. And so we can see more and do more with digital controls now than we used to be able to do with the pneumatic controls. The control systems of today now are interoperable because everything is electronic, everything is digital. And so the different control systems in a building, whether it's lighting, whether it's gas detection, mechanical systems, even security and fire systems, can all communicate with each other. And they can be networked now, not only just from system to system in a building, but from different buildings on a campus or even across the country or the world. The user interfaces in control systems of today now have just a wealth of data. And so with the customizable user interfaces, we can see dashboards so that facility managers or building engineers can at a glance see what a building is doing, whether their energy strategies are effective. They can see exceptions before even sometimes the tenants have an opportunity to raise an issue. They know that there's a problem and can address it. So tenant satisfaction is much improved. So ultimately, the original and modern day controllers function under the same concept of making the systems work together. But the way they work and the results have changed drastically. Occupants used to use control systems to interact with their equipment, and now the occupants are essentially taken care of by the equipment. And the facility managers and building engineers go to them for information. So we also have a much tighter control and finer control over the conditions of a building, whether it's comfort, cooling, or any of the other environmental concerns that control systems are used to address. So with present day technology, integration is one of the things that control systems offer, the ability to bring multiple systems together. They're very flexible in how they're deployed and what sorts of things they can address. Standardization has become a very key issue with the different protocols. And then the components and security of control systems are very important. So we have another poll question now.
Yes, we do. Thank you, Ed. So yes, and you'll see that on the screen now. So we'd like to ask everyone to cast their vote here too. And the question is, which feature with the systems the types of controls that Ed's been talking about, when you think about your buildings, which feature is most important to you? Is it integration of most any automated system that you work with? Is it the flexibility and scalability? Is it standardization? Is it having pre-built components available, or strong and secure software? Is that the biggest concern of importance to you? So please take a moment to let us know which one is the most important to you. Again, integration, flexibility and scalability, standardization, pre-built components, or strong secure software. And we will again show those results in a moment. Okay, so integration of most any automated system, more than half, 53% is the feature that's most important according to our attendees. So thanks for that. Followed by flexibility and scalability with about a third, and then standardization, and rounded out by the strong secure software. So thanks again, and thank you, Ed. Back to you.
So integration is one of the largest benefits of control systems today. Controls engineers have the opportunity, essentially limited only by their imagination, of what strategies they can use to make the different parts and pieces of a building work together. So a tenant may swipe an access card to unlock the front door, but the control system may recognize that that person works on a certain level, turns on the lights, turns on the mechanical system for their particular floor or suite. And all of these things we can do now with modern control systems because of the way that integration works. And the total number of different systems that we can integrate continues to expand more and more with the topic of standardization, which we'll discuss more in a minute. Flexibility and scalability of control systems today are also a very important aspect of controls. Not all solutions are the same for different applications. So whereas an enterprise level system may be useful for a customer with many campuses, there are also cost-effective and comfort-effective solutions for smaller buildings that may have fewer numbers of tenants or fewer numbers of pieces of equipment. Standardization has also become a very hot topic with controls, because there are so many different manufacturers and so many different types of systems that can talk together. There's been a strong push with ASHRAE and some of the other professional organizations to develop standards. So BACnet is a standard that's open and public. And there are many other standards that allow interoperability between control systems. Also, with modern control systems, cost has come down on deployment because there are many pre-built components that allow for the rapid rollout, installation, and design of control systems. So it's each system doesn't have to be individually crafted. Also, these components allow for trending of data so that strategies can be evaluated and user behavior can be evaluated, and we can actually verify and monitor that the system and building are performing as they're designed. It has become increasingly important to have strong, secure control systems with buildings. And so there have been big pushes from many of the major manufacturers in the control industry to develop strong, modern security systems built into the control systems to make sure that the risk to the facility manager is minimized. So with the modern controls, there are really many benefits, but primarily there's the efficiency gain from having the tighter envelopes and data to evaluate strategies, the lower cost of having the digital controls and the open standards, and then also the ease of use and accessibility for end users. If the facility managers don't understand how to operate the system, or it's difficult, then you're not going to get the full benefit of your system. So HVAC is the largest factor in an automation system typically. So maximizing the efficiencies is one of the best uses of a control system. A great example is automating variable refrigerant flow systems. So VRF consistently performs 25% higher in efficiency than traditional HVAC systems. So managing VRF through modern day controls adds another level of efficiency because the systems come with built-in sensors and built-in mechanical controls that use standard cooling and heating with best practices and strategies. So managing VRF and integrating other systems also adds another level of efficiency and supporting better overall management. So with the lower cost, one of the ways that we can achieve that is through operational awareness. So you can modify the heating and cooling strategies. We can use light sensors to measure the actual available light and dim lights, saving energies, or using blinds to reduce solar load. There's optimal start strategies and optimal stop strategies that help reduce use during peak times and can also allow building to coast at the end of the day to a stop rather than running the full schedule and saving money there. So there are also utility incentives for using modern control systems. Variable frequency drives and things like that allow building managers to capture those utility incentives. So demand response is another increasingly large opportunity for building managers and facility executives to use control systems to capture additional opportunities for savings. And then the third benefit is the ease of use and accessibility of controls. Modern control systems are no longer bound to a pneumatic panel in a mechanical room or a user operator workstation. Many control systems now are mobile friendly. They can send alerts, whether it's text alerts, email alerts, or they can actually just be operated from mobile devices. So untethering the use and management of facilities is another way that modern control systems are helping make better buildings. So quickly, let's take a look at some of the ways that we have implemented modern control strategies. We performed a project for doTERRA, and it's an international company that was founded in 2008. And they make and distribute essential oils, personal care products, nutritional supplements, and healthy living products. In 2014, they constructed a new global headquarters in Pleasant Grove, Utah. It's a 200,000 square foot headquarters with over 1,300 employees in the building. We use controls to integrate the different HVAC systems in the building, the boilers, the different alarms for the different mechanical systems, water fountain temperature and control, etc. Scalability for doTERRA was hugely important. And so they didn't want to have a control system that limited their ability to grow. So using a non-proprietary control system was also very important. They didn't want to be locked into a single vendor or manufacturer. So they wanted to be able to run anybody's system. And that's one of the things that we can accomplish with modern controls and the push towards standardization. So another case study is the Liberty Memorial Central Middle School. So this is a school system that's located in Lawrence, Kansas. Previously, their mechanical system was a 4-pipe. It was in need of replacement. And so they actually updated from 4-pipe to a heat recovery VRF system. So in addition to changing out the mechanicals, they also added a control system to fully customize the operation of the VRF equipment, but also to integrate into a single point of contact or single user interface the remainder of the mechanical systems that weren't changed out, or the mechanical systems that were not VRF. So the school wanted to have a control system that was built on a well-known standards-driven platform. The PSG group for Mitsubishi Electric sent a team of 4 individuals for a week to commission the system, which involves checking the operation not only of the mechanical equipment, but of the graphics and of point verification in the field. So the school has liked the performance of the control system so much that they're actually including projects to develop the same control system and bring 5 other schools into the same user interface. And so all of these schools will be operated from a central user workstation that is networked and accessible to anybody on their IT network. So, Kevin?
Great. Thank you very much, Ed. That overview provided quite an in-depth look at the history of building controls, along with a view into the current state of the industry and some really good application examples. It really shows the wide range of how the controls can be applied, especially in buildings a couple 100,000 square feet and above. The world of building controls really is fast changing, and it's really an exciting time to be involved in this category. I'm sure there'll be quite a few questions after all the information you shared this afternoon. A quick reminder to those on the phone to submit your questions through the presentation software. We've had a couple come in that we're really looking forward to addressing, and we really look forward to addressing any more that come in over the next couple of minutes. Today we've had a chance to explore the history of building controls, along with 4 trends that drive the industry: the demand for higher energy efficiency, the demand for space-saving flexible design, the demand for better control, and the demand for personalized comfort. The world of building controls is continuously evolving to meet these and other trends within the HVAC industry, and we believe will continue to evolve well into the future. So where does the industry go next? The once far out concepts of smart cities and connected homes have become realities, driven by the Internet of Things and big data analytics. Similar to the fast fading concept of work-life balance, which has shifted more towards work-life integration in recent years, our world is becoming more integrated. The innovation present within the electronic controls industry will connect our home life with our work life and everything in between. For example, our cell phones will be able to communicate with our cars, telling them to turn on and fire up the AC when we're leaving our desk for the drive home. And our cars will be able to communicate with our homes to adjust the temperature as we approach the house. And eventually, our HVAC systems may be able to adjust based on our body temperature or other physical conditions. Our lives will become more connected and more integrated in the coming years. So how does Mitsubishi Electric respond to this new normal? Our research and development teams are hard at work on innovations that take advantage of the Internet of Things to deliver smarter HVAC system innovation. Communication between the homeowner or building occupant and their HVAC system will become easier, quicker, and more efficient. Communication between the HVAC system and other connected devices within the home or building, such as smart thermostats, will become a reality, delivering enhanced operational efficiency to a building owner and its facilities management team. Stay tuned for exciting developments in the coming months and years from Mitsubishi Electric. We'd like to highlight 3 resources, among many others, that are available for your use after today's presentation concludes. These resources include our professional-focused website, MitsubishiPro.com, an overview of our Diamond Controls building management solution, and links to 3 quarterly newsletters, one focused on engineers, one on architects, and one on facility managers. Thank you again for your time this afternoon and for your attention while we walk through the in-depth nature of building controls. I'll now turn the presentation over to Anne for additional information and to begin the Q&A session. Anne?
Great. Thank you, Kevin, and thank you, Ed. And thank you all for sending in your questions as the presentations rolled along, and please continue to send in any if you do have any more at this point. Yes, we do have some time for some Q&A, and we look forward to jumping into that now. I did want to mention to the audience, Kevin, the resources that you pointed out there on the screen. Everyone in the audience, you will receive a post-webinar email with live links to all those resources, so you'll have those right at your fingertips afterwards. So, okay, we'll jump right in. Let's see. We have a question about a specific scenario, so to speak, with controls. And that question is, how is a kilowatt demand response program integrated into automated controls? So in your experience at Mitsubishi Electric, how does that work?
That's a great question. I know, Ed, you talked a little bit about demand response, and you touched on that as a feature that you see more and more when it comes to putting in building controls. I'd love to hear your experience on how it's integrated into the automated controls and how a facility manager can take advantage of a demand response program.
Thanks, Kevin. There's a huge push right now in demand response programs nationally. I know that right now one of the standards that is very popular with many of the utility companies that we've been meeting with is a standard called Open ADR. And so there are actual drivers that integrate into the controls hardware that communicate with the utilities and the HVAC systems, so that during an open AD or during a demand response event initiated by the utility, the facility manager can actually configure the response of the building to that event. So it may be the ability with the control system to configure that the mail room or public spaces like lobbies may have a larger response with set points, but executive offices or meeting rooms may not respond quite as much. And so that's one of the options. I know that we also have a device that was engineered here in our engineering center, which is a USNAP interface. So that's another device that works with the CTA 2045 device that is a different path for demand response. So there are several options, and I know that there is a huge push in development for that right now.
Great, thank you very much, Ed. So on to the next question. We'll jump to a more strategic type question. If the question is, if I am in business development for a building automation firm, how do I show the value to a prospective client who's not quite ready to jump all in, with the controls?
And that's a great question. We often hear, what do I need for my building and what do I need for my application? Not what could I potentially have, but give me exactly what I need, the lowest price, lowest integration option. I know, Ed, in your experience from a training perspective, especially looking at building automation and controls, how would you advise your trainees to address that question?
So the hesitancy for investing in controls is understandable, but one of the biggest things that we can offer now is that controls gives a building owner, if they're investing in the building or if they're giving the facility manager, it gives them visibility into the building. And so that's going to make for happier tenants because the conditions in the building are going to be at much more comfortable. They're going to be happier. You're going to have fewer complaints. You're going to have less engineering staff to respond to hot calls and cold calls because you can pre-address those issues. You're going to have visibility into the exceptions with your building. So if you have a mechanical failure or you're having a system, you're going to be able to very frequently identify those before they become problems with the building. You have now the ability to look at trend logs, and trend logs are one of the most valuable resources to building engineers because they can actually identify and look back historically at the performance of the building. And so if there needs to be a modification or if there needs to be additional capacity added, they can actually make that make an informed decision by looking at what the building has done. So another thing is with a resale value of buildings. If you have a modern control system, that building becomes a much more attractive investment than a building with no control system or limited controls.
Okay, thank you. So you had talked about some of the case studies during the presentation and mentioned some variable refrigerant flow technology that Mitsubishi Electric does. So can you talk about maybe somewhat what some other VRF manufacturers are doing to integrate control systems, maybe how that compares to what you all do?
Sure. We go ahead, Ed.
I'm sorry. For the most part, VRF manufacturers are offering what are called backnet gateways. So it's a device that connects to the VRF system and provides visibility on typically one of the standard protocols into the system so that existing controls in a building can operate the VRF. Mitsubishi Electric can offer that as an option, but one of the differentiators for us is that we actually have a seamless branded solution where we are directly operating both the VRF equipment with controls, but also any of the other ancillary systems or pieces of equipment in the building. So that's one of the ways that we are definitely different than most of the market.
Thank you. And with Mitsubishi Electric, who performs the installation with these systems?
And I'll let you jump in on that one.
So The installation can be performed several different ways. We have diamond contractors across the nation who purchase equipment from distributors and perform the installation. But we also have a solutions group here in-house that engineers custom control solutions and different offerings, such as energy apportionment panels and things like that. And we're starting up system installer partners across the nation to actually execute the installation of the control systems.
Thank you. Now, I did want to jump on. We have time for about one more question here that's come in, and it's really talk about existing buildings. And I know you talked about an existing school project here in the presentation earlier, so might lean toward that. But what experience does Mitsubishi Electric have with non-Mitsubishi equipment, as would be expected to be found in an existing building? And then how do I know that it'll be integrated correctly? What needs to be taken into account with an existing system?
That's a very important question, Ann. And you look at existing buildings. I think that's, and I'll let Ed speak to the expertise of the team. But that's one of the strengths of the team that we have here is we've taken the time to invest in learning about other pieces of mechanical equipment within a building, especially parts and pieces that come together to form the HVAC system. That's definitely a differentiator that's there. And Ed, I'll let you speak a little more to the training that goes into it and the personnel skills that really come into account when you're integrating non-Mitsubishi Electric equipment.
Sure. One of the things that we have as a strength is that the majority of the people in our group do come from other manufacturers of traditional HVAC equipment. They come from other contractors who might see a wide array, of different pieces of equipment. And so there is a huge, diverse, broad skill set that we have that we can tap into across the country, where people have seen other pieces of equipment, other manufacturers, other protocols. And so we have a large number of really experts on staff that we can tap for experience and guidance. And then also our own control solutions department, we are developing and executing training constantly, where we are trying to advance the expertise and capabilities of our staff constantly.
Thank you. So any other comments on the integration in terms of what facilities managers should know ahead of time when they are embarking on this? And then I guess we'll close it out.
Ed, anything from your perspective? And then I'll take the final comments.
Sure. Just know that if it's a new installation, if it's a retrofit, if you have an existing control system or you don't have a control system, we have an engineered solutions offering that can fit almost any opportunity on the market.
Yeah, and I think I'll expand upon that as we close out here, Ed. One of the things that really guides our development and the industry's development efforts are ease of use and making it easy for a facility manager to manage their building. We know that HVAC and control systems are just one part of a facilities manager's day-to-day responsibilities. And what we want to do is not make that the part they dread, not make that the part that they really don't want to dive into and assess and fix. So accessibility and ease of use are two of the big things that drive the development on the control side. And we want to make it as easy as we can for a building owner or facility manager to be able to view what's going on with their system and make the necessary adjustments and changes, ultimately leading to happier tenants, fewer complaints, and a better job going into the office the next day. So at the end of the day, it's around ease of use and it's around accessibility. With that, I'll just say thank you on behalf of Ed and myself for your time and your attention this afternoon. We definitely look forward to sharing this information with you. We were glad we were here this afternoon. And as you review the presentation after the fact, after you receive that email from the team, please don't hesitate to reach out if you have any further questions, comments, concerns. We're happy to put you in touch with the right folks and make sure those are addressed.
Thank you. Thank you, Kevin, and thank you, Ed. And of course, I want to thank our audience for attending today and listening in and sharing your questions as well. And thanks to Mitsubishi Electric for sponsoring the webinar. A recording of the webinar will be available online at facilityexecutive.com, as well as you'll also receive that email with the additional resources you see there. Thank you very much. Have a great afternoon.